rational means that the equation is going to look like a fraction. This is our parent graph equation. 1 over x. It looks like a fraction. Remember, parent graph is the simplest possible one. And this is called a hyperbola, and it has 2 branches. Here is what the graph looks like for f of x equals 1 over x. It has 2, these parts are called branches. It also has 2 asymptotes. Do you see the 2 branches and do you see the 2 asymptotes? And then the domain is really ugly looking. Way back in August, we learned set notation. This means x such that x is an element of all real numbers except x cannot equal to 0. This is the asymptote. This is the same thing in interval notation. This means everything from negative infinity except the asymptote at 0. This means all real numbers such that y is an element of the real numbers. Y is not equal to 0. That means all real numbers except 0. You can actually write it out in words if you prefer. All real numbers except 0. You can write it out in words if you prefer. That's what it looks like in interval notation. That means everything from negative infinity to positive infinity except 0. This little symbol right here is a U shape. It stands for union. It means and. This part and that part. You can also write the word and if you choose. Do you see that the graph is in 2 parts? That's why the domain is in 2 parts. That's why the range is in 2 parts. Because the graph is in 2 parts. Does that make sense? That if the graph is in 2 parts, the domain and the range have to be in 2 parts. And then, just like we have done before, we're going to move the graph right and left and up and down, and we're going to reflect it, and we're going to stretch it. So let's skip over here to example number 1. Example number 1. On the graphs, I always start with the asymptotes. The asymptotes should be very obvious to you because we put dotted lines in there for you. So this is the horizontal asymptote. Where does the horizontal asymptote cross the axis? 1, 2, 3, 4. Which axis does it cross? Y equals 4 is the equation for the asymptote. The asymptote is not 4. The asymptote is y equals 4. You need to have the y equals in there as part of your answer. This is the vertical asymptote. Where does the vertical asymptote cross the axis? It crosses the x-axis, so it is x equals 2. Now the parent graph had the asymptote here, and this has been moved over 2. The parent graph had the asymptote here, and this has been moved up 4. Do you see a connection between those 2 numbers h and k and the asymptotes? I hope you do. Okay, so in order to write the rational function, the next thing we need is the a. The rational function is going to be written in this form. And so all we have to do is figure out the A, and then we'll have everything to plug into that formula. And so back over here on the parent graph, from this intersection of asymptotes, this graph has a key point right here that goes up 1 over 1. That means on this graph, the A is equal to 1. That's the parent graph. Over here on our example number 1, does this go from the intersection of the asymptotes up 1 over 1? It does not. That means there's been a stretch. So, can you find a pretty point? Do you see that that point right there is a pretty point? And so you count like you would count similar to slope. What is the rise over the run? 3 over 1 is 3. So now I have all of the pieces to fill into that formula. G of x equals the A, 1 over x minus 2 plus 4. Why is this a positive 2 here and a minus 2 there? X is still backwards. It's still lying to you. You still have to change the sign on x, just like we've been doing all year long. The domain is all real numbers except this vertical asymptote. The domain is all real numbers from negative infinity to positive infinity, except there's a break at 2. The domain is connected to the vertical asymptote because the domain is, of course, in the x direction, and that is x equals. That's where there's a break in the x direction. The range goes with the horizontal asymptote because that has a y equals right there. The range is negative infinity to positive infinity, except there's a break at this asymptote. And just like the graph is in 2 pieces, the range has to be in 2 pieces, and the domain has to be in 2 pieces because the graph is in 2 pieces. Example number 2. I start with the asymptote. Where does the asymptote cross the axis? This is the origin point. And so this would be, but that's not right. That's not enough. Which axis does it cross? You have to have the y equals as part of your answer. This is the vertical asymptote. It is at -1. It crosses the x-axis at -1. You have to have the x equals as part of your answer. And the x goes with the h and the y goes with the k. Now we have to find the A. The parent graph from this intersection point goes up 1 over 1. Do I have a point right here on the graph? Not on the branch. That means that the A has either a stretch or a compression. Do I have the graph up here in this top part at all? It's down here in the bottom part. It's below the asymptote. That means that it has been reflected. It's going to have a negative sign because this is under the asymptote. Now, are there any pretty points here at all? No. So I am going to have to guesstimate. I am going to use this point right here and estimate what that is as best I can from the asymptote that appears to be below the asymptote about half a unit. And so when those are compressions, you just have to estimate what they appear to be. Once again, I am going to fill in this equation, this transformation equation. This is negative 1/2, 1 over x plus 1 minus 3. This is a minus 1. When I put it into the equation, it changes signs. The domain is in the x direction. This crosses the x-axis. The domain is everything except the vertical asymptote. Negative infinity to positive infinity, but there's a break at negative 1 where there's an asymptote. The range is associated with the horizontal asymptote. It's negative infinity to positive infinity, but there's a break at this asymptote. Does that make sense to you that the domain and range have to have two parts? Because the graph has two branches, two parts. Problem number 3 doesn't have a graph, though, does it? Example number 3. How are you going to find these asymptotes without any graph? How are you going to find the asymptotes horizontal? Okay. Well, that would be true if it was written in this same form, but this is x, and that's x squared. So the first thing we're going to do is, just like when we were solving, what do we need to do with that denominator? Factor it. Now, do you remember that every day, I think last week, most every day, I wrote up on the board with great big red letters, the denominator cannot be equal to 0. The denominator cannot be equal to 0. And most everybody could do this part on the test. X cannot be equal to negative 3. X cannot be equal to 3. Remember doing that when we were solving? Well, what you just found was the asymptotes. The reason x cannot be equal to 3 and x cannot be equal to negative 3 or positive 3 is because that's where the asymptote is. What x cannot be equal to, the reason it can't be equal to those is because there's an asymptote there. So you just change the not equal to an equal sign. What about this other one? What does this number right here do to my graph? Don't know what the graph looks like, but whatever it looks like, when you have a minus 6 down there at the end, what does it do? And so it's going to make it go down 6, and what's going to go down 6 is the asymptote. It's down 6. So that asymptote is going to be at negative 6. Problem number 6 on your homework paper. I always start with the asymptotes. It's easier for me to figure out the asymptotes. That is the horizontal asymptote. Where is the horizontal asymptote located? Is that acceptable? No. That is not an acceptable answer. What axis does that cross? Now it's an acceptable answer. Okay, what about the other asymptote, the vertical asymptote? Okay, so this is going to be 4 and this is going to be 2. The parent graph would go up 1 over 1. Does this graph go up 1 over 1? The A is not 1. Matter of fact, the A isn't even on that side of the graph. The graph is down here at the bottom below the asymptote, so this A is going to be negative. It's going to be reflected because this is below the asymptote. Now, can you find a pretty point? Right there? And so you count it like the slope, rise over run. And so what would that be? 3 over 1 is equal to 3. And so you fill in the equation A, 1 over x minus 4 plus 2. Now, I just want to mention, make that more readable, that you will see this same equation written like this. If you multiply the negative 3 times the 1, that's equal to negative 3. So these are equal to each other. These are two ways to write the same thing. A lot of times you will see it written like that. Okay. Now the horizontal asymptote has a y in it. So the horizontal asymptote goes with the range because it has a y in it. So the range is going to be from negative infinity to positive infinity with a break at 2. The vertical asymptote has an x, and so it's going to go with the domain negative infinity to positive infinity with a break at 4. Any questions? Might have a question on the next one, so let's look at problem number 7 also. The vertical asymptotes come from the denominator. The denominator is x minus 1. That cannot be equal to 0. If I solve that out, x cannot be equal to 1 because that's where the asymptote is. X cannot be equal to 0 because that's where the asymptote is. Now, how do you find the horizontal asymptote? There it is. I found it. But on this one, there's not anything over here. So the asymptote is at y equals 0. This assignment will be due on Wednesday.